Welcome to Half-Hearted. I've been really looking forward to this one. Joining me all the way from Regina, Saskatchewan. He is an amateur astronomer. He is an astronomy educator and co-host of the Actual Astronomy podcast. Thank you for joining me, Chris Beckett.
Yeah, thanks so much, Jay. Good to be here this morning.
And I also want to give a shout out to Jenna Hines, the executive director of the Royal Astronomical Society of Canada, for connecting us. And also, I know before you were saying that you co-host your podcast. Who's your co-host?
Shane.
Shane
on the Actual Astronomy podcast. Yeah, we do that together and have lots of guests and basically talk about visual and amateur astronomy, the type of gear that you need, and how to get started in amateur astronomy. It's what it's all about.
Cool. Yeah, I look forward to talking more about that. So what I was saying before is here. What kind of comedian wants to have an astronomy conversation? So I just thought here's my credit.
Oh, nice.
This is one of the first pieces of decoration that I wanted for my podcast space. So
cool.
Yeah, almost nobody knows what it is.
It's the mirrors from, it looks like the octagonal mirror sections from the Webb Space Telescope, I think.
That's right, the James Webb Space Telescope for anybody who doesn't know. Okay, so just to get into it, give me a little bit of background about you. So I don't know if you're born and raised in Saskatchewan. How old are you? Just the Coles notes on Chris.
So I was born in Truro, Nova Scotia, and lived in Nova Scotia for the first 30 or so years of my life, or actually a little bit less. And then we moved to Ontario, and I lived in Ontario for about 3 or 4 years. And then about just over a dozen years ago, moved out here to Saskatchewan. And so out here, I'm enjoying some of the darkest skies that you can get in Canada. And
okay.
Some really cool astronomy opportunities that come with living in a place that doesn't have as many people to do astronomy. So
yeah, that's really cool. When I was I don't know where you lived in Ontario, but my first place was I want to talk to somebody about astronomy, but I had no an actual person, right? And I didn't know where to start. And in Richmond Hill, I remember that there was an observatory, so I just looked up the observatory, which is how I got to the Royal Astronomical Society. But yeah, I would imagine that if you have an interest in astronomy in a very populated place, then you're competing for opportunities with the good gear.
I suppose so. Yeah, actually, I was in Richmond Hill last week at the observatory. Strangely enough, I'd never been there before, and it was one of those things that I wanted to do. But yeah, I think what it boils down to here is just that when you don't have as many people, there's just not as many people who might be interested in doing astronomy classes or setting up telescopes and doing these sort of activities. And I have a lot of fun doing that. So yeah, it's been really nice living out here. I had the opportunity. I taught for 12 years. I taught non-credit astronomy classes at the University of Regina. So that was a lot of fun when I was doing that.
Yeah, that's really cool. So it means that you really know what you're talking about.
I don't know. Yeah, so I know about it's a strange thing because as an amateur astronomer, I know the names of many of the stars, like probably the 100 or so brightest stars, and how to find all the constellations that you can see here in the Northern Hemisphere, and a lot of what we call the deep sky objects like galaxies, nebulas, and star clusters. And this is something people are interested in knowing. And a lot of the time, people will take an astronomy class from sort of a person who's professionally trained in astronomy or astrophysics. But that individual, more than likely, it might know a few of those things, but they're not really going to be able to teach you how to learn your way around the night sky or show you how to use a telescope or when to see what and exactly the mechanics of the sky as you see them when you're standing underneath it, which is a very different experience. There's some, but for the most part, professionally trained astronomers are going to be experts in their field. I went to a talk last week on fast radio bursts and then waited in line with that individual while they had a look through the telescope too. And it's kind of neat that we can be involved in astronomy and contribute in this way.
Mm-hmm. And I definitely want to get more into amateur astronomy. How did you get into astronomy? Like, what sparked that interest for you to the point where, you know, as an amateur astronomer, I'm assuming like this is your hobby. This is what you're dedicating your non-professional work time to doing. And presumably you'd probably like to do more of it if you didn't have a day job. I have a similar description, only it's for comedy.
Yeah.
But yeah, so what sparked your interest in it?
Yeah, so for a day job, strangely enough, I do work at a university, and I do work in research, and I do work in scientific research. I just do not work in astronomy or astrophysical research. So sometimes it does seem a little bit odd where I am working on a scientific research project, and then I go home at night and do my own very different type of
Yeah.
astronomy and science. So it's kind of a funny thing like that. But what got me going in it was my mother. When I was a small child, she would always be encouraging me to, if I was going out with my friends, to camp out in their backyards when we were little, she'd always be saying, like, stay up late and watch for the meteor shower, or getting me to go out and look at the lunar eclipses when they were happening. So that was always a lot of fun, and that really kind of got me going. But they would never buy me a telescope. It was always, and I think this was a good thing. It was always something I wanted to get. I was always striving for it, but they would always say, "Oh, well, so and so bought their kid a telescope, and it just sits in a closet," and that's sort of par for the course. And maybe if they had done that with me, it would have been the same story. But I think because they never did buy that for me, I had to kind of wait until I was earning my own coins, so to
Yeah.
speak, and put some hard-earned money down on the line. And of course, when you're doing that, maybe you give it a lot more thought and consideration than you would have if you're a 12-year-old kid and your parents are just simply buying it for you. So yeah. So finally, when I was about 17 or 18, I started saving my money, and about a year or so later, drove to a telescope store, bought a telescope. It didn't fit in the car, took it back in, and got my money back, and went home and ordered one online.
Whoa, it didn't fit in your car.
It
Geez. So
didn't fit in the car.
you went big right away.
Yeah, unfortunately, yeah, too big. It was kind of funny. I was buying it, and just as they were sweet, the guy said, "Can I see your car?" And I'm like, "Why?" And he's like, "This is a big." I didn't quite realize how big the telescope would be, and yeah, it didn't fit in the car. So I was so disappointed, and drove home with this. And it was far to the telescope store. It was like I'm gonna say about a 10-hour drive.
Oh
And
my gosh.
so anyway, it was one of those things where I had to go and order it online. So yeah.
Oh, man, I want to ask what type of telescope it was, but if you answered, I would have no idea. What?
Well, yeah, this was just the standard telescope. I think it's a great telescope to get started. We always are very often recommend an 8-inch f6, what's called the Dobsonian telescope. Basically, it kind of looks like a cannon.
Yes.
It's a sonotube, which is just one of those concrete forms, and it's on what we call a rocker box. It just looks like a piece of furniture, really.
Hmm.
And what's nice about them is that they're relatively cost affordable. You can get into this for around $1,000, and it has a mirror in the back. It's a Newtonian design, has a mirror in the front that angles it out into an eyepiece, and they're very simple to use, cost affordable, and there's no electronics or anything. You can get them with those, of course, but if you really want to learn your way around the sky and really get the most out of it, we do recommend just getting the base model, just the base unit, the most affordable model of an 8-inch f6 Dobsonian telescope, and that's a great instrument to get started with.
Oh, that's really cool. And when you got your telescope, what was the first thing that you wanted to look at?
I can't remember what the first thing I wanted to look at, but I know the first thing I looked at was Mars, the planet Mars, which
Okay.
was something that always fascinated me. And yeah, it's too bad I should have thought ahead. I have some sketches that I've done of Mars in recent years, and it's something that I've continued to look at. And uh, now I have special telescopes. I have a special telescope pretty much just for looking at Mars. So
Really?
yeah,
And
pretty cool.
how detailed could you get a look at Mars with your first telescope?
Not that detailed. You could see the polar caps, and you could see some of the dark, dusky markings, and maybe that it wasn't quite a circular disk. But yeah, you can actually start to see some detail. And
Hmm.
then if you do want to probe deeper, then you're looking into getting some higher quality optics. But to get started, a lot of it has to do with training the eye. It's not
Hmm.
Astronomy isn't something you can really buy your way into so much. I've known a few people that get into this later in life, and they have more money than I did at 17, and they go out and buy, and to be honest, I mean, the stuff is expensive, but it's not as expensive as, say, getting into fishing if you want to buy a boat, or
Hmm.
sailing if you want to buy a boat. It's much less expensive than that.
Well,
And
yeah, when you talk, because I grew up, playing guitar and stuff, and you talking about the, $1,000, entry fee. I'm like, yeah, that's, in guitar speak, that's not that bad.
yep,
Because like for us, it's like usually the cutoff is like $2,000. You want something, anything that's good is going to be $2,000, and probably in the last few years that's gone up to like 2.5 or 3.
yeah,
But yeah, the barrier to entry doesn't seem that significant, and
yeah.
uh, and it seems as though has the like the equipment that an amateur astronomer would use, has that been increasing in quality over the years? Because I feel like I've seen headlines about like amateur astronomers, discovering something on Mars that like hadn't been seen by the actual scientific community before. And if what I'm saying doesn't sound accurate at all, then feel free to correct me.
Yeah.
But
No,
I feel
it
like,
is.
the amateur astronomy community actually, contributes.
Yeah, for sure. The equipment has, increased in quality leaps and bounds. Like my first telescope, which is now, I guess, about 25 or so years ago, it eventually just fell apart. It wasn't really
Mm,
that well constructed. But now, and even 15 years later, people were buying pretty much an identical telescope, and those telescopes are still around. That's what they're
oh
using.
wow.
And yeah, that's what they use for public outreach in a lot of places. And yeah, just the ability for people to put various cameras on them and take images of the planets, whether it's Mars or Jupiter or what have you. See, the amateurs, the great advantage of the amateurs is with the professional telescopes, you only have a handful, maybe 24 or a few dozen of these large professional telescopes around the world, with literally thousands and thousands of individuals trying to get time on those instruments. Versus with the amateur astronomers, you have millions of people all over the world, each with their
Mm,
own telescope, who can point it at whatever they want on any given evening if it happens to be clear. And so, for example, amateurs are continuously monitoring Jupiter right now. So there's
mhm.
always an amateur telescope pointed at Jupiter, imaging Jupiter. And if something happens, like if there's an asteroid impact on Jupiter, there's a really good chance an amateur astronomer will catch it. Chances are it's unlikely to be caught by a professional observatory unless they happen to know it's going to occur.
And is that do amateur astronomers constantly have eyes on Jupiter simply because it's there's so much action on it?
Well, yeah, you can see a lot on Jupiter, even in a small amateur telescope. Like the very smallest instruments, like a 50 or 60 millimeter telescope, will show you the bands of Jupiter and the moons of Jupiter. And if there's a moon going across the planet, you can see that. You can see its shadow cast on the cloud tops. You can really see quite an incredible level of detail. And once you get up into some larger and higher quality optics, you can really see quite a bit of detail on the planets. For example, like when Mars was at its opposition before last in I think it was 2000 or 2020, that is, you could see the clouds, passing over Amazonas, which is one of the large desert areas of Mars, just through the eyepiece of the telescope, right? And this
Mhm.
isn't, this is a telescope that's designed for looking at Mars, but it's a telescope within that range of your guitar, right? In that
Yes.
$2,000 range. That can start to show you that level of detail on the planet Mars, which is super cool to see.
Yeah. Are any amateur level telescopes capable of seeing Neptune to any degree?
Oh yeah, you can. I mean, you can see Neptune with binoculars from a
Oh.
reasonable site. Yeah, Neptune is about 7.8, or what we call about eighth magnitude from the darkest skies. Have you ever been out? I don't know if you've been up to Algonquin Park or any
Mhm.
of those places, but in those areas, you'll be able to see stars into what we say is the sixth magnitude. And from the city, you might only be able to see the fourth magnitude stars, but with binoculars, you'll be able to see about eighth magnitude or
Well,
so. So
the
yeah.
reason I ask about Neptune is I wish I could remember his name, but he was one of the leads on the Voyager missions, and he was saying that Neptune up until that point in the late 70s and 80s, it was just like a blue dot that they didn't know anything. They didn't have any details about it at all. That
Mhm.
when Voyager 2 went by and they saw the great dark spot on the bottom of it, like that was a total unexpected detail for them because they had no idea that was there previously. So I
Mhm.
think what I meant more specifically was like, can you like, yes, you can see that there's a blue dot, but can amateur astronomers see any actual details? I don't mean like super details, but more than what NASA could see in the 70s.
I think, yeah, about that level, I'm gonna say.
Okay.
But those are pretty custom setups. I know of two amateurs, one in France and one somewhere else, and they've got some pretty sophisticated, like 14, 16-inch telescopes in some pretty sizable observatories, getting into maybe not the guitar level, but maybe into owning a pretty nice, you know, sailboat level
Yeah,
of
that's what I was going to say. A
expenditure.
car.
Yeah, maybe even getting a little bit into the luxury car range. But you know, that's what some people do. I don't drive a luxury car. I just drive a hatchback. But I've got my own observatory, right? So
Yeah, well, yeah, I was never a car guy either. I'm like, if I have money for a car, I'm gonna spend it on, really great guitars. That's where my priorities would lie. What
yeah.
does how does the when you say amateur astronomer, I think what most people might think is you don't get paid to do it. But I was saying earlier, it seems as though that amateur astronomers actually contribute a lot to what science and the space sciences discover. So what would you say is the difference on a more practical level, other than just having it be what you get paid to do, between like an amateur astronomer and somebody who's paid to do astronomy?
Yeah, I think it's just like you said. Essentially, as amateurs, what we're doing is just doing it out of the love of it. That's what amateur
Hmm.
means, is you're just doing it out of the pure love of it. And certainly that's what I do. I think of the amateur astronomer, though, as being those individuals who are doing like public service and perhaps writing papers or doing podcasts, or teaching classes, or contributing in some way. And then certainly there's those that are stargazers as well. People maybe, like, I think of the general public as just liking to go out and look at the stars, not really worrying about which star they're looking at, or spending too much time at the eyepiece. So there's all kinds of different levels that the people can enjoy it. But for sure, amateurs provide a great service. Sweeping the skies. People are still discovering comets and asteroids, and observing meteor showers and making contributions in that way. Watching variable stars. There's many stars that pulsate. You can see those pulsations if you watch them night to night. And I always think it's really neat to do some of this stuff as well. It's pretty cool. It's the opportunity to go and look at the original article. I always say,
Hmm.
I don't know, have you ever been to the Louvre?
No, I haven't.
You should go. It's really cool. And you go, and the Mona Lisa's there, and she's sort of in this alcove off to the side, and you have to wait in line to go and see her. And her, like, I don't have a very big computer here, but I have this little screen. Like, the painting of the Mona Lisa isn't that big. It's just like
I've heard that.
a good sized laptop screen, like, turned on its side. But so many people, everybody goes to Paris, wants to go, and everybody goes and sees the Mona Lisa, right? You have to do this. Um, because it's a rare opportunity. You can't go and see the Mona Lisa every day. But if it's clear out tonight, I can go and look at Jupiter, just like
Hmm.
a professional observatory or somebody who's gone and studied planetary sciences could do. So we have that available to us. I guess in a way, it's like music, right? Like, even though you have to go and pay for the guitar, nobody owns the chords. Nobody owns the notes, right?
Yes.
Yeah.
Yeah, nobody can bogart the research, right? You're
Yeah.
all studying the same subject.
Yeah, and the other really cool thing, and I don't know if other sciences are as much like this. Certainly, the other stuff that I do isn't as much like this for obvious reasons, because we're dealing in healthcare. But with amateur astronomy, you can go and find professional researchers who are interested in doing the professional work that you might just be interested in as an amateur. For example, I was looking at the star cluster one night. I was at a star party. I was doing a star tour with a bunch of people, and my friend was there, and he's a really good amateur astronomer. He said, you should find out more about one of those clusters you pointed out. I never really thought much about that cluster before. And so I said, oh, well, I'm sure I can find something. And you couldn't find that much out. And I was like, oh, that's kind of
Huh.
weird. They don't really know much about this. So I contacted, there was a few folks down at Pennsylvania State University that were actually researching the star cluster using professional observatories. And they were really, really excited to hear from an amateur astronomer,
Oh.
because they didn't have a good photograph of what they were studying because the telescopes they were using were so large, and the wavelengths they were using to study the stars in the star cluster were so different and not really visually stunning that they were trying to figure out a way to get a good image of it. And I'm not an astro imager, but I have a friend who is, and we went
Hmm.
out one night and we took a photograph of this, and they went and presented their findings at the International Astronomical Union. And when they were presenting, they used our photo as their backdrop in front of, like, I don't know how many hundreds of people there at the
Yeah.
International Astronomy Union. It was really neat. And they cited us in the paper and everything. Of course, we just did it for our own fun and enjoyment, but it was really cool.
Yeah, but your contributions are being put towards the larger science of understanding the universe that we observe. That's so cool, man. Like,
Yeah.
yeah, that's
And
really awesome to hear.
and it turned out why it was so important for them is that some of the stars, and they circled them for us and they sent it back to us. Some of those stars were G2 type stars, which are the same as our sun.
Oh,
And
okay.
and there's some of the stars that they want to go and see if they have exoplanets around, because they feel like if there's exoplanets around some of these stars, they could be stars that could habit life that's more similar to maybe what's on Earth than some of these other ones.
Hmm. That leads to my, I guess it somewhat leads to my next question, which is, what is the difference between an astronomer and an astrophysicist?
I think these days those terms are used interchangeably a lot of the
Hmm.
time. I always like the question of, sometimes you get the question, people confuse astrologer with astronomer. So
Yeah,
yeah,
that's far more damaging.
it is. But Jay, do you know the difference between an astrologer and an astronomer?
An astrologer is somebody who is a con artist, and an astronomer is somebody who looks at the stars.
I was going to put it that way, but I was going to say the astrologer is somebody who uses the stars to tell the future of a person, and
Hmm.
the astronomer is a person who can tell the future of the star.
Ah, okay.
So I always like that. And regarding the astronomer and the astrophysicist, well, back about 150 years ago, you had your astronomers and then you had
Hmm.
your theoreticians. Okay. And so the astronomers they could even be people like me that would be lucky enough to do enough astronomy or discover enough comets or something that they would be recognized enough and would be able to perhaps finagle a job at an observatory looking through big telescopes. And so
Hmm.
they were there sort of night after night looking through the instruments. And then you had your theoreticians, and these eventually became astrophysicists. Eventually, those two have really sort of merged together, where you have your astrophysicist going to a location to put instruments on a telescope, and it's a little bit blurred. But typically, the astronomer is the person that's focused on the observational aspects of astronomy versus the astrophysicist who might be doing more theoretical work. But I think it's a little bit more blurred now from the folks that I've talked to. A lot of them are pretty aware of like how things work, and then they want to go and test their theories. So it's sort of a little bit of both now, I think.
And I'm just trying to. I always. There are so many different directions that I want to go. But I would say, what is your like astronomy bucket list? Like, is there any piece of equipment or place in the world that you'd like to go to do astronomy, or because
Yeah,
I feel like we're talking about stuff on Earth right now, but I want to
yeah,
get into what's going on outside
yeah,
of Earth very soon.
yeah.
But yeah, like are there pieces of gear that you would love to try?
Yeah, I guess there's some. I was in Ontario last week, and I was having lunch with my friends Peter, Tom, Mike, and John, and they're people who are building large telescopes, and I'm trying to convince them to bring some of the newer, larger telescopes that they've been building out here to Saskatchewan. Of course, in Ontario, you don't have the dark skies, but you have lots of people and have friends back there who have these beautiful large instruments. Out here, we have lots of dark, clear skies, but I only know a couple people with large instruments.
Mm.
So yeah, having that kind of opportunity. As far as places to go, I really want to get down to the southern hemisphere because of the pandemic. We had our trip. We were supposed to go to New Zealand for maybe 6 weeks or so around Christmas last year. Like we were
Hmm.
supposed to be there a year ago, right now, in fact, and that ended up getting canceled because of the pandemic. It was something we'd planned for a long time, and my wife had she's doing some collaborative work with she's not an astronomer either, but she does research too. and
Okay.
she was collaborating with some folks down there, and supposed to go down for 3 or 4 weeks, I think. And I was going to tag along and go up to Lake Tekapo, which is where they do the astronomy there. I thought it'd be awesome, but it got canceled because of the pandemic. Worst thing that
Yes.
happened, of course, but yeah.
Yeah, I was maybe gonna go to Vegas for my 40th, and that got canceled. So it's like the same.
Yeah, yeah, it's too bad. Yeah.
Um, so you were saying earlier that you were fascinated by Mars, and still are. That you have a telescope that's specifically
Yeah.
dedicated for it.
Yeah.
So what is it about Mars that fascinates you?
It because of what it looks like. It looks like another planet, which may seem like a strange thing to say, but you can see there's polar caps. You can see that there's dark areas that represent some of the other features on Mars. There's light areas which represent the deserts. You can start to, on really clear and still nights, I've seen some of the just little undulations on the surface that indicate where one of the volcanoes exist, and things like that. So you can see these things. It's very fleeting though, and it's like when you look at the moon with your unaided eye. When you look at the moon with your eye, you can see like the man in the moon, some of the dark and light features. That's really kind of the way
Mhm.
Mars appears through the telescope. You can see a lot of different things, and then if the condition's still up, you can start to see some of those surface details. Yeah, but it's fascinating just to see, and because it's only there for a short time, comes around about every just under 2 years, every 20 months or so,
Oh,
and
okay.
then yeah, you have about 4 or 5 months where it's really good to look at, and yeah, it's just like a fleeting thing. But a lot of the time, I'm mostly somebody who's looking at what we call deep sky objects like clusters, nebulas, and galaxies, and that sort of things.
But just to finish on Mars, I feel like NASA has, we've had multiple, or I say we, the collective we, but NASA has a number of probes on Mars, and there's been intense study of Mars, especially it feels like over the last 20 years or so. Can you give me like a breakdown of like what are the things about Mars that we know now that we didn't?
Well, that there was flowing water on it.
Flowing.
That
Okay.
yeah, for sure there was flowing water. They found all the same type of geological features on the surface of Mars that they find on Earth in deserts where there had once been flowing water, like these little round nodules that have to form in flowing water. And they've also discovered that some of this water ice may exist just below the surface. They've had landers that go and have scratched away at the surface with like little shovels that kind of look like the Tonka shovel that maybe you had
Yeah.
as a child. And just right below the surface, they've found quite a bit of ice and different materials like that, and just some of the rocks that exist, and the appearance of weathering from not only wind and sand, but also likely from the passage of water over them. They've been able to see different landslides that have occurred in some of the crater walls, and just how the planet is changing. They've even recorded impacts on Mars of little asteroids and meteors and that sort of thing. So yeah, they've been able to see quite a bit, measure a lot of the stuff in the atmosphere, observe the dust storms as they occur, and yeah, it's a pretty fascinating place. But yeah, wouldn't want to live there.
Well, and that leads me to my next question, which is that what do you make of Elon Musk wanting to, us to visit is cool, but like setting up more permanent outposts out there? Because my understanding is, and this is where I would love to be corrected, is that one of the reasons that Mars is not a great place to live would be the fact that it is losing atmosphere all the time. That its mass isn't such that it can maintain it. Is that correct?
It's yeah. There's a few reasons. It's not as large as Earth. It's
Yes.
only it's somewhere between the size of our moon and the Earth. It's actually closer in size to our moon,
Hmm.
and it doesn't have as much mass, but also it doesn't have the same. It has very limited magnetic sphere around it, so it
Yes.
doesn't have the same protective qualities. See, the Earth is a unique and rare place, and one of the things that always makes me concerned about this type of conversation about going to Mars and setting up camp there or whatever is that it makes people think like this is a viable option. This is not a viable option because see, when the Earth was forming, there was another planet that collided with it, and that planet was called Theia. This is all like been well proven in the astrophysical record. And the core of the primordial Theia and the primordial Earth, they merged. So
Mhm.
Earth, in a way, has slightly more gravity than it should for its actual size. And then we had this nice moon that formed around us. The
Mhm.
combination of having this extra mass in our core and a moon that goes around and creates these beautiful tides that we have in the oceans of the Earth, and that, again, likely that the creatures that now inhabit the Earth evolved in the tidal pools, which were a result of the rising and falling tides from that moon. This could be a very rare set of circumstances, and makes it most of the time, a very nice place to live. These same sort of conditions could be very rare indeed in the universe, and let alone Mars is not one of these places. It's not a nice place to go and drop down and hang out. You're not gonna be like, it's not gonna be like camping in Arizona or something. It's going to be pretty terrible.
And what do you make of the because I feel like I really resonate with what you just said about the this idea that the conditions of Earth, and especially the conditions that make life possible, might be more rare than we think. But I also feel like there's science. We'll talk about it after, but I heard somebody from NASA say life is so plentiful in the universe that there's a version of you and me having this conversation right now. And to me, that seems a little fantastical, if I'm honest. And so, what do you make of the headlines where I feel like we see it at least every few months. There's a new like Earth-like planet discovered, Earth-like planet discovered, and when you read the fine print, it's like it's got one feature that's similar to us,
Yeah.
and it's most likely does not have life, let alone something that would have advanced intelligent life.
Yeah, has one oxygen particle per million. Yeah,
Yes.
it's one thing the Webb is doing is pointing its instruments at some of these exoplanets and measuring their atmospheres. And I think there's even a telescope they'll put up after Webb that, and maybe even Webb to a certain degree might be able to dig a little deeper on this. But yeah, I don't know. I think that it's a pretty remote possibility of having anything like that occurring. You know, it's just it's in the realm of possibility. How likely is it? I think it's just very unlikely, because it's sort of a numbers game. You have
Hmm.
an infinite amount of stars in our galaxy, several billion stars perhaps,
Hmm.
but the chances of other beings existing while we exist, that's the other bit,
Yes.
um, may be exceptionally small. Maybe there's been other civilizations, but I think it would be more like in Carl Sagan's book Contact, where there are other beings, but they're sort of few and far between. That's sort of the moral of his story. I think the reality is that there's probably just not that much life out there, unfortunately, at least any sort of intelligent life. They might find different types of life, I think, is probably that's probably what you're looking at, because we sort of have a species centric way of viewing things, where we look at what's around us and we determine what life is. But there could be other forms of carbon life and non-carbon life and that sort of thing out there. So yes, there could be life, but who knows?
But intelligent life probably not. So, what do you think the odds are of finding life on Europa?
Hmm, don't know. It could be, a place there could be life. The issue with Europa, it could be the absolute perfect environment because it has a deep ocean with salt and it has tides.
Hmm.
And when you mix those things together, you could get life. The challenge with Europa is perhaps not its composition, but that it's in the radiation belts of Jupiter, and those radiation belts would essentially just sterilize it on a continuous basis for billions of years, unfortunately. And so whatever evolves there could be a very different form of life again, right? but
Mm.
but it could, again, it could be microbial in nature, and I think probably there is microbial life out there. I mean, almost like I feel very certain of that.
Hmm.
um, and I think that's something that NASA and others need to be careful of, because even if it is a different type of life or a microbe type of life, that's still life that has the right to exist on that world that it evolved to exist on. Just because it's
Hmm.
maybe not walking around or driving cars and polluting its own environment, doesn't mean it has a right to exist, right? So you be very careful with that. You go and send a probe down in one of these places. If it's not properly, conditioned, I suppose you could inadvertently wipe out the one life form that had managed to scrape out and evolve to live in that, that harsh environment, right? Like you're changing the environment.
Yeah. So you're even us forget about, because when you say that, I'm thinking like microbes from our planet inadvertently get on their planet and either one wipes out the other because they would be unfamiliar. Well, I mean, it's tough to say, right? This is all hypothetical, right? Who knows if the type of life from our planet could even interface with the life from another planet, I suppose.
Well, and I mean, chances are we, like if history is any predictive measure, our life would probably end up wiping out the other life,
Yeah.
some sort of catastrophic comedy act, because you don't know what's going to interfere with another, life form that is scraping out an existence somewhere else. I think they're going to be careful about these things.
And because presumably NASA knows the same things that you do about the unlikelihood of there being life on Europa, the effects of radiation. So why would they want to send the Clipper anyway?
Just to find out, I suppose.
Okay.
Just to I think because it's in the realm of possibility. I think it's an interesting idea to go and send it and to develop the technology to go and drill through the ice there, which is only, forget what it is, but it's like 2,000 feet thick, or it's thick.
So pretty thick. That's what if I recall.
Yeah, but it's not like insurmountably thick. I mean,
Mm-hmm.
you can develop that kind of technology here on Earth and go and look for it. But I sure hope they're careful,
Yeah.
because I don't know. There's the whole thing. I don't know how much it's going to change if they go there and they find microbes that are existing 2,000 feet below the surface of the ice on Europa. I'm not sure how much that changes things here, but hopefully they do it in such a way that doesn't interfere with whatever life is there.
I feel like that would probably have a significant effect, right? Because that would, well, I think they would need to find out where they may have come from, but I certain religious views that put life on Earth is specifically unique.
Yeah, I don't know. Yeah, I don't. You kind of broke up there. I didn't quite.
I was saying like you were saying that discovering life on Europa wouldn't be all that huge if it was microbial, but I feel like that would kind of wreak havoc on religious systems that think that life here is unique.
I don't know. I kind of feel like any of the religions that I've learned about seem to be fairly resilient, and
Okay.
yeah, and I think that there would be ways of each religion kind of coming to an understanding with that, depending on what their cultural perspectives and the belief system is.
You were talking about the radiation on Europa, and I wanted to go back to that. So, do you think that the radiation on because we're exposed to radiation from the sun always, and our magnetosphere, and do we have an ionosphere? We've got spheres, right, that protect us, but Mars has less of that. And so, would any potential colonists be exposed to high levels of radiation? And do they have would there be measures to protect them?
They'd be exposed to massive amounts, and I don't know that we have the technology. I suppose they could develop it, but it would be so cumbersome.
Mm-hmm.
You would just be exposed to so much. Like even if you buried the whatever in the center of Mars, you would still be exposed to vastly larger amounts of radiation and solar particles, and these are high speed particles that damage cells, right?
Mm-hmm.
We do get some here on Earth. In fact, by taking a flight, like I did last week from Regina to Ontario and back, you're increasing the amount of radiation and the damage that your cells receive simply by flying another 30,000 feet up in our atmosphere. Even living at higher altitude, you do.
Wow.
But living on Mars is going to be just exponentially, like, it's just going to be like basically living outside of in fact, you're living outside of our atmosphere at that point. So it's kind of like all bets are off. When the astronauts are in the space station and they're trying to sleep, they're impacted by so many of these particles, that when they close their eyes, the particles can hit their retinas and light up, and
Whoa.
it can be a bit disturbing for them. So I was chatting with Chris Hadfield once, and he was telling me about this. I think it was him, and yeah, some strange things like that occur. Of course, they're only up there for a couple hundred days at a time at most, and even on the International Space Station, which is way above our atmosphere, they're still within some of the protective boundaries of the ionosphere, and they're still in some of the bounds of the magnetic sphere. And they have well protected areas in the International Space Station they can crawl into if things get particularly bad for a short period of time. But yeah, I don't know. There's a lot of technological leaps to overcome. It's always neat to see what they can come up with to overcome them. I think it's a big challenge to overcome for perhaps not the greatest place to visit.
Well, yeah, it reminds me of, I don't know who would want to do that. It's like, how do you feel about living in underground concrete blocks?
Yeah.
Like, right? Like, have you seen that show, The Silo?
No.
But it's like you like live in the silo voluntarily. That's right. You're deep underground in a giant thing that protects you from radiation, but you will never see the sun again. That seems like it doesn't seem particularly happy.
Yeah, I mean, I'm all for scientific exploration. I think what NASA and JPL does is really cool. I've met with some of the NASA scientists, sort of a long story, on the work that they do on Mars, because there is a strange Saskatchewan connection, and so they've come here, and it was nice to have lunch with them and go to some of their talks. So I really appreciate and understand what they do. But even in those conversations, that's what's forming my ideas here. These aren't just ideas that I've had from reading a magazine or something. I have a deep interest in Mars, and I've met with, I don't want to say who they are, but I've met with some of like the leading scientists, the past 20 years who have been in charge of those missions, and kind of had lunch with them and discussed these things. And that's what's forming my ideas on this. I'm not shooting from the hip.
No, I mean, when I've stated my opinion, I'm very much shooting from the hip, but I feel like I know a little, to be like, to know that the Earth protects us very uniquely, and that those protections don't exist elsewhere, and also knowing that Mars is the closest thing we're going to be able to get to, and after that, missions to the outer planets are near impossible. And those are going to be conversations for humans well into the future, but they're not for us.
There's also a trade-off, Jay. Like if we're doing like collectively as a species, we're choosing what we're doing, we're choosing other things we're not doing. There could be other things that could have more like value, right, to the humans as a species, or just in pure scientific exploration. We kind of know a lot about what happens on Mars already, and as a huge Mars fan, it's kind of neat. But it would be neat to have other probes, like a probe that goes around Io, which is one of the other moons of Jupiter, which has like a volcanic surface and is one of the most beautiful places in the solar system. It would be nice to have some more research on that. Be great if they went back to Titan, which is one of the moons around Saturn. Be great if they did a mission to Uranus or Triton, which is one of the moons around Neptune. Or some of the other large bodies in the asteroid belt and some of the dwarf planets. There's a lot of solar system to explore. There's a lot they don't know about comets. One of the companies I worked for sent a mission to one of the comets. They were part of the Rosetta mission. And
oh, cool.
The fascinating part about that, actually, I have one of the mission mugs downstairs that they gave me. I didn't do anything on the mission. I was working in a completely different project. Like, again, I never work on the astronomy stuff. I just work for places that do some astronomy stuff, and they never let me at the controls for some reason. But with that mission, they went to land on a comet, and when they went to land, they thought the comets were kind of like dirty snowballs or like maybe a hard snowbank or whatever. And when they went to land the Rosetta spacecraft on the comet, it just bounced off. They even had like they were explosive powered kind of like stakes that would go into the comet to like help reel it down or like pin it down to the surface. And they could not penetrate the surface. It was harder than anything that they could have
Oh.
imagined. And there's all kinds of, and this was something that people thought they had a pretty good understanding of, right? Oh yeah, we know
Mhm.
what these comets are made of. We know what's going to work or what's in the range of possibility. And it didn't work, right? It was something that was just unknown. It would be neat to understand some of these other targets and some of
That
these other.
sounds similar to the Mars lander, because if I recall, they had stakes coming off of the feet because they thought that it was going to have like a really thick dust layer. Is that
Oh,
correct?
okay. I can't
No,
recall it. Something like
that's
that.
okay.
Yeah.
Um, you were talking about some of the outer planets and Io and Triton, and that reminds me of how. So I saw a documentary called The Farthest Voyager in Space. I don't know if you've seen
Okay.
it. It's a PBS documentary.
I may have. It's ringing a faint bell, but
If you can find it, I mean, I tried to find an actual physical copy of it that I could buy because I don't want to steal it, but I couldn't actually. The only thing I could find was a Blu-ray for like that was only playable in the UK. So
Mhm.
I just torrented it, but it's a documentary that basically details the history of the Voyager missions. And they talk to all of the scientists who are, the engineers who built it and the scientists who were analyzing the data as it came in. And that documentary is what really got me fascinated it like really attracted me to space science, and where I started listening to what's NASA's actual podcast called? I can't remember it now. Anyway, but they were like talking live about when the New Horizons was going out to Ultima Thule and things like that. And where am I going with this? Which is like, why aren't we doing big audacious missions like this to the
Mm.
outer planets? That I guess is it too hard?
I have no idea. Yeah, yeah. I mean, imagine this is pretty tough for them to construct the craft, and then it's also going to take a long time, right? So
Mm.
you think of New Horizons when I think it was 11 years or whatever. It was like a very long period of time between launch and when it actually passed by Pluto, and then of course it's only the several days around closest approach that it's sending back all this material, and then it's sort of one and done kind of thing. It's a very long week there when it's going past, but it's very limited in the amount of time it can spend at one of these places, unless they go and try to get into orbit around it, which of course is going to, take even longer still, right?
And I would imagine that would, from an engineering standpoint, would present a lot of challenges because you need to get it to a certain velocity to get out to those outer planets within a reasonable amount of time. But then you would have to get them to stop to be able to actually like stay there.
Yeah. Yeah. That's why they focus more on the interior planets, because they can do a gravity assist from other planets, and then they can sort of gravity break as they're coming into Jupiter or Saturn or whatever it is. Once you get much past Saturn, it is much more difficult to do that, and it takes so long, right? It
Mm-hmm.
takes a long time.
I guess yeah, I'll move on to that later. You were talking about you're interested in nebulas and clusters.
Yeah,
Did you
nebulous
say?
galaxies, clusters.
So what drew you to that, and what are the like? Tell me about those.
Well, they they look very different than they do in photographs, especially now, but they just look remarkably beautiful through the eyepiece to see for oneself. You
Mm,
can really see just this. When it comes to clusters, you can see a lot of stars, and many stars have different colors and different configurations. And then just to be able to go and look at the original article, the original item that is out there in space is again a unique experience, because it's just always up there and available to you on any clear night. The other thing that photographs and diagrams and models or whatever don't really take into account is the scale and the grandeur of it. So when you're looking at the Big Dipper, like if you look at a photo of the Big Dipper, if I held one up, it'd be like, like this big or something or
Mhm.
whatever. And if you say, well, no, it's really big, you have to kind of describe it. Or if you're looking at it on your computer screen, it's just going to be this big. Even if it has nice background or foreground objects, you can kind of get a sense for how big it is. But when you're standing there, just even looking at like the pattern of the Big Dipper, which is part of the constellation Ursa Major, it is really quite huge on the night sky. Like, if I hold my arms, it's bigger than you can see on my screen. And looking at anything like that in the universe through a telescope is kind of like that. Like you are standing there kind of witnessing it. A few weeks ago, or I guess about a month or so ago, I was looking at a nebula up in Orion in the early morning. The nebula is called Messier 78, which is just above the belt and to the left or to the east. And I was looking at it through my small telescope, and a meteorite or a meteor went through and left a smoke trail just while I
Oh,
was looking at it. So I was doing a sketch at the time, so I sketched in the smoke trail. I was showing that to my friends. But you can see a lot of this stuff happening in real time. It's really neat just to be able to stand there and watch it play out. What you can see is truly incredible.
it's and the scales, the size scales in space are just unfathomable. Like when you talk about nebulas and clusters, I think of the pillars of creation, and you have no idea like what the size of those are relatively, but it isn't it enormous?
Yeah, so the pillars of creation are up on the scutum and sort of where serpens, scutum, and aquila meet. Maybe they're in serpens. Um, and what they are is star forming regions. There's stars that are being born in a huge set of clouds that are on the border of these constellations. And so they have these towering, billowing pillars of basically dust and gas. And in some areas in these pillars of cloud, the dust has compacted down
Hmm.
due to gravitational forces, and it's forming stars. And those stars are starting to shine through and move out from the nebula. Sort of funny, the M16 or Messier 16 um, pillars of creation, as it's become popularly known. It's not that easy to see those through a
Mm.
telescope. So yeah, again, I should have brought my sketchbook up here, but I was sketching that a few weeks ago um, as well. It is one of those interesting things where you can go out and see this for yourself, but you do need a dark sky in
Hmm.
order to start to see. We call that the Eagle Nebula because there's kind of like this little pattern there that looks like the eagle, but it's very difficult to see through the telescope. Let me tell you.
Well, I imagine a lot of the like what James Webb has even been able to discover is it's a bunch of different filters all being combined at once to get the final image. No.
Yeah, and they're using infrared light. The
Hmm.
James Webb isn't a visual wavelength.
Okay.
So it looks at things not only differently because it's doing long exposures and collecting a lot of data, but it also is looking in a different bandwidth of light than what we can see with our eyes, more or less. Yeah.
And there was so much. Like, I remember counting down to when James Webb was going to be launched, and it got delayed from Halloween to Christmas, if I'm not mistaken.
It was delayed
And
so many times, Jay. So
yes.
I gave a presentation. I gave a presentation in 20, I think it was 2016 or 2017, because the telescope it was going to be launched within the next year or something like that. I can't remember the exact year. And then this past February, I was invited to give another lecture on the Webb Space Telescope at the university, and it had just started giving back some of its data, and I had looked it up at the time, and it had been something like 5 years or something between the lectures when they thought it was going up and then
Oh
when it
wow.
actually started. Yeah, so it was delayed like sort of innumerable times, and it's one of those things I can't quite in some ways fathom why people are so excited. I think the reason perhaps is that people have been in some ways it's the successor to the Hubble Space Telescope, But infrared light, it's of great scientific value,
Mhm.
and I think that the technologies and what they're doing with it is quite fascinating from a scientific perspective. I think it's kind of neat that the public has um, really become quite interested in what that instrument is doing, because this one's pretty technical. With Hubble, it's all in the visual, so you kind of get what you can see. It's just a
Mhm.
really good view of what you can see, versus the Webb, which is sort of gone over that theoretical line. It's not what you can see, but people are, you know, very excited about it, which is kind of cool.
Well, it is cool, but I think it harkens to, and I'm just gonna put myself out there, but I feel like there's something about observing the universe um, that's deeply human. Like, I don't know if you did you see that clip on the internet of the monkey who had only been inside its whole life, and they release it and it looks at the sky, it sees the blue sky for the first time.
Oh,
Did you see that?
no, I haven't
Okay,
seen
so they released this monkey, and like it was viral on the internet, and it's just like it sees the blue sky for the first time. It's like, whoa, like, and I think the reason that was, it went viral, or that people thought that was interesting, because it's rare to see an animal be truly awestruck.
it.
And for us, when we see space, it's one of those few things that truly creates awe in us. And I think the reason why we're interested in James Webb and what it can do is because I think that deep down we all, this is my hypothesis, is we all really want to know where we come from.
Mm-hmm.
Right? Like we've got ideas, but truthfully we have no idea. Like we can't even agree now on like the age of the universe. Like even that's up for debate. And I feel like so much of space exploration is driven to find like the quest to find life seems to be a prime motivator in space exploration, because we want to understand where we come from. And I think why people want there to be aliens is because we're hoping that the aliens have the technology to, one, explain where we come from, and two, make it so that we don't have to go to work anymore, that they'll give us the infinite energy machine that will like solve all our problems. I don't know how I was going with that, but but yeah, I feel like there's something very
I
human
have a
about.
couple of comments to make.
Yeah, well, no,
So,
I'd love to hear.
so,
Like,
so,
I love to put my ignorance on display. So
so
wherever.
one of the interesting sort of, when I was in university, I studied philosophy. So
Hmm.
humor me on this, is that there's nothing that says that other intelligent life in the universe would have the same curiosity that we do.
Hmm.
There could be, in essence, like, you could hypothetically say that there's a lot of life out there, and it's existing on a lot of planets, and those planets might even be not so far away, astronomically speaking. But there's nothing to say that any of these other intelligent life forms that are out there would even care. They might
Hmm.
not even think about what else is out there in the universe. There could be all kinds of reasons for that I won't get into. It's just something to kind of ponder. I think a lot of the time we think about, if there's other life, it too must be, looking up in the sky or whatever and wondering, you know, but there's nothing that says, and even our species, it seems like we go out of our way to blot out what we can see of the universe.
Hmm.
Strangely enough, we point lights into the sky at night when everybody's, for the most part, asleep, that require a lot of money and maintenance to keep running, which essentially don't do anything. So
Yeah.
even our species isn't perhaps as curious, or many of us aren't as curious, or don't do the things that would facilitate actually exploring the universe as much as we might think we do.
Hmm. Oh, I think that's pretty fair. What do you make of it? Are you interested in any of this UAP stuff at all? This whistleblower stuff? Have you been paying attention to it at all?
A little bit. So this UAP stuff, this came about in the early 2000s, and I look at this stuff. I try to look at this stuff very objectively.
Hmm.
What I noticed is that this these type of events, and the ones that are really catching the public's eye, are things that have happened since the introduction of certain technologies.
Hmm.
And it could be artifacts from certain technologies. I work in technology, and I certainly have seen a lot of strange things with technology, but it's a result of the technology, perhaps not a result of unidentified aerial phenomena. So another way to put it is that myself and several millions of my associates around the world are every night looking at the stars, and we communicate openly and freely with each other on the internet, or through my podcast. I reach thousands of people, and just nobody is talking about having seen any of this stuff.
And
It just, yeah.
I think that nobody talks about that. Nobody talks about the fact that people who are watching the skies and space constantly never see anything.
And it's not even that it's not that we're not trying to see stuff. Like, we are looking, and myself, I always thought it'd be pretty cool. Like, in fact, like when I was much younger, when I was in my teens, like my friends and I would go out to look. And I remember some of the first nights out, we saw stuff, and we were just like blown away the first few times we went out to dark sky sites. But all of this stuff amounts to one, like satellites. It's shocking how many satellites you can see. Like, and this is way back. Now you can see tons of satellites. International Space Station is ridiculously bright, and
Yes.
probably accounts for a huge number of these sightings. There's probably a dozen other satellites that are nearly as bright. And then, yeah, we're just not seeing it. There's nothing stopping us from seeing this stuff if it's happening. I think a lot of it has to do with perhaps the maybe something in the technology, because I don't know that it's like, is it supposed to be that it's sensing something that's beyond the visible wavelength or something like that? But I don't know. It just seems like this stuff only started occurring when they introduced certain technologies. But what's interesting, so this is sort of the weird part, if you ask me. Here's your conspiratorial bit from my side of the fence, is that the weird part about all this that strikes me is, at the same time, there has been some interesting work here on Earth to maybe investigate some alien spacecraft, and it's been by a reputable university, Harvard,
Mm-hmm.
to say the least. And one of their researchers there has been investigating sediments in the bottom of the ocean. And that research involves looking for perhaps spacecraft that have made very long journeys across the solar system. The fact that the Earth is a very small target, but if there is a lot of life in the universe, and you think about things that have escaped from our solar system, that eventually perhaps something may have impacted the Earth, and if it did, it might have left remnants in the sediment in the bottom of the ocean. And from what I gather, I'm not going to cite the source, people can look it up, but they did say they found perhaps some interesting evidence of combinations of certain elements and materials which wouldn't naturally occur together. And
Oh,
that
okay.
that kind of stuff, I think that sounds really interesting, because if you think about it, like, if there was this many spacecraft visiting the Earth, then they should find some of them in the geological record, right?
Yes.
Because people always point to this, and maybe that's the place. Maybe that's the place to look. But I really think perhaps those would be good, interesting investigations for people to be doing. People should look up that article from Harvard. That
Okay.
one's interesting. I gotta say. That's the one that I thought was really interesting. While at the same time, they have all this stuff on CNN and stuff, and I'm like, to me, I know a lot of people are interested in that stuff, but to me, the interesting piece was the stuff that they weren't talking about in the media, which is kind of one of those. It sort of made me feel like the people often who are watching this stuff that's playing out are saying, "Oh, well, finally, it's coming out in the news." And then there was actually an article, or it was a journal paper actually, that came out, and I was like, whoa, that's kind of weird, because to me, that was the story. That was the
Yes.
really interesting piece. So is there a cover up? I don't know.
I don't know. I
I thought that was
don't know what
really
to make
weird
of
that
it.
they were occurring simultaneously because my friends were watching it. One of my friends was watching it at work, and I was like, meh. I said, if you want to see the and so I sent him that, and he was like, holy crap. And I'm like, yeah, that's the interesting one. This other stuff is kind of it's sort of a curiosity, but the other one is
There's no fighter pilots involved, so they don't know what, or secret alien bodies, so it's not as fantastical. I'm definitely gonna look that up.
yeah,
That's
you
really
want to look
cool.
that one up. I wish I had it
Yeah.
off the top of my head, but it's like a journal article from Harvard, from a Harvard University tenured professor. That one's kind of interesting to read. If people are interested in that stuff, they should take a look. The other stuff, I don't know. Like, yeah, we
Yeah.
just haven't seen it. And then, a couple times I've seen once I saw like one of the actual, they were launching I think one of these Starship ones or something. I saw one of the separations this
Okay.
summer. Like I just walked out and I saw it and I was like, what the heck is that? And then I was like, you go to the right website and you have to know this stuff. Like it's really difficult. And you're like, okay, because they don't like to publish where the orbits of some of these things are. Like it's not like you can
Yes.
find it sort of after the fact. And then I was like waiting the half hour. And then it was like, okay, like there was one of these SpaceX spacecraft that was in this spot in my sky when it did the separation. I was like, that was pretty cool because I stood there for a minute watching. And I said my wife was inside. I said, you got to come out and see this. She came out and looked, and we looked, and we're like, wow, that's pretty weird. She said, what is it? I said, I don't know. But you really had to kind of do your sleuthing and know that it was going to be coming up here in a period of time.
And yeah, there's a lot going on up there that they don't tell us. Like I remember I went to, it was in the beginning of 2019. I went to the Kennedy Space Center, and they had like talk to an astronaut. Yeah. And it was a guy who had done 3 missions, and he was just like, this was, the first 2 missions were these, and the third one was top secret. And like you could and he's still not allowed to talk about it. So yeah, they're doing so, and presumably that is military related, but there's stuff going on up there that they don't want us to know.
And it could even be simple things like, I know there was a big trend a number of years back where people were launching balloons into the upper atmosphere or space or whatever. Well, if you kind of knew where, like, you know what I mean? Like somebody could interfere with things or cause problems. Like you could theoretically, if you kind of knew how, like where things were going to be at certain times and stuff like that. And I can understand some caution around that, of course, especially when they're trying to launch different things. So I keep losing you, Jay.
Oh, that's okay. It's the internet. Well, we are at over an hour anyway. So Chris, I really want to thank you for your time, and I feel like I learned a lot, and I'm going to look up that Harvard article, but thanks for coming on and taking the time to speak with me. I feel like like I got a lot out of it.
Yeah, if people want to know more about like how to find stuff in the night sky, I do produce an astronomy calendar as well. I'm not sure if I mentioned that or not.
No. I mean, I did want to do like a proper wrap up, but yeah, like Chris Beckett, you run it's the co-host, the Actual Astronomy podcast, which I guess is you throwing shade at the Astronomy podcast. I don't know what assholes run that one, but you should listen to the Actual Astronomy podcast.
Yeah. People can go there and check out our podcast where Shane and I talk about amateur astronomy and what people can see in the nighttime sky. And if people want to find out some of this stuff for themselves and they're in Canada, they can get in touch with the Royal Astronomical Society of Canada. There's centers across the country, which are basically like astronomy clubs in each major city. And I produce a calendar. You can get a calendar to put on your wall, one of those old things, and it will tell you what to see, what the big events are on whatever nights of the year that stuff is occurring. So you can go to rasc.ca, and there's a store option there. You can order one of those calendars. I think they're $15 or $20 or something like that. And yeah, people can tune into our podcast or just go out and enjoy the night sky. You don't need to know what you're looking at in order to enjoy things. But if you see stuff moving up there, it's probably just a satellite.
Awesome. Well, like I said, Chris Beckett, everybody, thanks again for coming on. I appreciate it.
Thank you.